Hello, students. This video will give the instruction that we need for this little mini unit describing how acids behave as solutes. Remember, we've just really talked about what makes an acid is the formula requirements or are the formula requirements. So for example, we know that's hydrochloric acid. As chemists, inorganic chemists, we acknowledge that acids contain the hydrogen ion. Well, how we define an acid. So we recognize its role in the formula, but acids are hydrogen ion donors. They give away that hydrogen ion to something else. That is how acids behave as solutes. They ionize. Ionization is the reaction of acids. And for now, it's with solvent, and it's going to be with water to create. And it is a chemical transformation, but it's to create ions in solution. But as we'll see in a moment, we end up creating a certain molecule that gives acids their characteristics. So let's take HCl, for example, and let's place it in water. Well, what makes this an acid is it gives away the hydrogen ion. And it won't give away the hydrogen ion if there's nothing to take it. So H2O bonds with the donated hydrogen ion, forming H3O plus. So this lost this hydrogen ion, and it gets attracted and actually bonded, forming what we call the hydronium ion. And then we'll just have remaining what is left after the hydrogen ion has been donated. And we recognize that's going to be a liquid. This will be dissolved in water, an ion dissolved in water, and an ion dissolved in water. So acids create free-moving ions. They will light the light bulb. They are electrolytes. All right. Now, there are 6 acids that get a special title. I think the acid that we're probably most familiar with is hydrochloric. But if we take a look at the periodic table and find chlorine, it's placed in the halogens and then use that as a marker and move downward to HBr and HI. So those 3 we know are vertically. What are some other acids that we've used in lab? HNO3, H2SO4, and the 6th is HClO4. All right, so HCl, HBr, HI, hydrochloric, hydrobromic, hydroiodic acids, nitric acid, sulfuric acid, perchloric acid. These are strong acids. So the scary characteristics that induce fear in us when we know we're working with an acid, it's from high concentrations of these in solution, because all that we put in creates hydronium. If we have 100 HCl molecules, they will react to create 100 hydronium. And it is this that makes an acid an acid. So when you taste something that is sour, it's hydronium. It's not the original acid, it's hydronium. Things that have very low pHs, it's hydronium. What reacts violently with metals, it's hydronium. Now, any other acid, and there are thousands of them, thousands. So if we take, how about halogen above chlorine, HF, or how about H2CO3, or H2S, or HC2H3O2? These are weak acids. It's interesting that there's no middle ground. So strong acids 100% ionized. Everything that we put in makes all that much hydronium. Where weak acids only ionize 1 to 3%. We ingest acids, we apply them, as makeup items and hair products and so on. So why are they not scary? Well, for example, acetic acid is vinegar. That plays that's an ingredient in many of our food products. Well, when this reacts with water, it is only a partial production of products. In fact, for every 100 of these, we only get about 1 to 3 hydronium. Again, being an acid, it gives away that hydrogen ion. And then we have acetate remaining. Still an electrolyte. This would just barely light the light bulb because we don't have a high concentration of ions. So acids ionize, that is the chemical reaction to produce ions. Acids are giving away the hydrogen ion. There's different strengths. You're either all creating product or only a little bit creating product. Have these handy, just like the solubility rules, because we need to be able to, in making ionic and net ionic, know which are written as ions and which are not. So whenever we have a bottle of vinegar, it is mainly existing as this molecule, making very little ions. But when we have a bottle of strong acid, whoa, it is pretty much all existing as ions. All right.